Welcome to my talk, Herding Llamas in Your Own Flat. What will we talk about today? So, we will start with a short introduction, what is Arcore and what is Sceneform, and then we will take a look at different parts, what you need when you want to build your own AR app, like model import, AR calibration, object placement and creation, then shadows and animation, and there will be code in the slides, so you don't have to take pictures. All the code is on GitHub, and there's on the last slide is the link again. So, first, short introduction. I'm an Android developer since Android 1.5. In 2014, I founded my company Smart as Apps, doing mostly freelance work in app development. And I started to work with Sceneform in January 2018 as part of an early access program with one of my clients, the Otto Group. We made the app Your Own Augmented Reality. It was presented at Google's AR booth at the Mobile World Congress this year. It was also part of different presentations at the I/O this year. So as I already said, we will have a sample app. And what do we want to do with a sample app? So we want to be able to place llamas and fences so that the llamas don't walk through your flat too much. So no llama hairs in your bathroom, for example. We want to be able to touch them and get a reaction. And the llama should move, but they should avoid other llamas and fences. So that's the task for today. And now a short video how that will look like. So first, short calibration. Now we have the floor. So somewhere we need a fence. That might be a good spot. A little bit rotation, so looks good. And then we can start placing our llamas. There's the first one going away from us. I don't know why. And the second one also doesn't like us. So that's the sample app we want to create today. And first, let's start. What is this Arcore? Arcore is Google's augmented reality framework. It's the successor of Project Tango, but with a nice change that you don't need special hardware. So in theory, it should run on almost every Android phone that is fast enough to handle these calculations on the device. And how it works is it finds features in the real world and keeps track of them so that you can add virtual objects to them or place information on them. And no matter how the user moves in the room or rotates or does whatever with his phone, Arcore should keep track of that point. Who of you has looked at the Arcore sample app last year when it was launched? Okay, quite a few. You would have noticed that there's a bit Arcore specific code in there, but a lot of OpenGL stuff. So the question was, should we all start becoming 3D developers and start digging into OpenGL? And fortunately, we don't have to. Google released this May at the I/O Sceneform. It's a lightweight 3D rendering engine, which is also nicely integrated with Arcore. It does all the initialization for you. It connects the virtual world with the world from Arcore. And it provides an easy start for new AR projects and helps you to link everything with the renderer below Sceneform. So this renderer is called a physically based renderer. If you want to get to know more about what is a physically based renderer and what's below the hood there, you can look at the Google I/O talk from Romain, building AR apps with the Sceneform SDK. There he talks in detail about what's the renderer that's below Sceneform. So, we want to know how to start with our app, and we have two options for that. One is we use the AR fragment from Sceneform. That's the easy part. You get everything you need. This AR fragment, it handles getting the camera permission. It checks whether Arcore is installed. If not, it prompts the user to download it from the Play Store, handles all the installation process for you, and it also provides some standard gesture support so that you can easily rotate, scale the objects that you place in the virtual world. The other part would be AR Scene View. That's basically a surface view, one that you would also use to do usual OpenGL stuff. And you have to do all the Arcore in it on your own. So this is more relatable to the kind of apps you did with the old Arcore sample app. So when we want to start with an AR app, so there are two options. Either you build an app that's based on boxes and spheres, or you need some 3D models to make it nice. And yeah, I'm not a 3D artist, so I need to find some good models online. And yeah, Google provides us with Poly, which is a platform for getting 3D models. You can just search there, download the files. Then you unzip them, put them in your project folder, and then easily import them using the Sceneform plugin in your Android Studio. And that basically, that's it. The Sceneform plugin will add 2 new Gradle tasks to your project. And one of them creates a so-called SFA file, which is a Sceneform asset. That file defines how the different files. So you have a OBJ file, which is basically the geometry. You have different textures, like different PNGs, and which PNG is used for which channel, and all these different informations, they are stored in your SFA file. And in the second step, there's a tool that converts all these different files into one file, the SFB, a Sceneform bundle, so that you just have to put this one in your app, and Sceneform knows how to load it and how to show everything included. Now that you have like 2 new Gradle tasks for each model, you might think, okay, if I do like an easy sample app with 2 or 3 different models, that's fine. But if I want to, for example, have a web shop and I want to add 500 models, that would mean I've got 1,000 new Gradle tasks in my build Gradle, and at least one of them is called with every build, so that might get really messy. So the other option that I found is to do it with a script. If you take these steps and you run them with --info, you see that they're basically only calling one command, the long one down there. But you can go from there and build your own script that calls these steps instead of going through adding every file manually through the Sceneform plugin. And yeah, then your build Gradle is not cluttered with 3,000 lines of model definition. Yeah, this one is creating the SFA file. But be careful when you do this. The SFAs that are created are best guess. So it works well if you just have one texture and a model, then everything is fine. But if you have more complex models with different textures, then it gets messy, so you will have to fine-tune it on your own. Luckily for us, these SFAs are a JSON-like structure. I use a Python script to basically take away what's in there and write it new in a correct order. And when you're there, you can also do some extra tasks like calculating bounding boxes for your models, which unfortunately the build tool also does not do for you. So usually the bounding boxes are just a cube with each side is one unit long, so it doesn't really help you with most models. And yeah, the build tool just takes all your textures and put them in one bundle. And you might want to downsize them on the way so that, we are running on mobile. We have a small screen. And you might not need these high-quality textures. If you have done everything like that, then you just have to call the last command line. And that's an easy one because all the work was done to create the SFA file. Now, Sceneform knows what different parts you want to put in that bundle, and it just creates the bundle. So now we have the model, and we want to start with placing objects in the real world. But of course, Arcore needs some information to recognize the world, to know okay, where are there planes, where can I put things, and a good start is to give it a little help, which just means to tell the user to move the phone so that the camera has different angles and Arcore can start finding planes and feature points there. Luckily for us, if we use the AR fragment, it's included. We have the possibility to change the view that is shown to maybe give it a better fit to your brand. And it also automatically disappears as soon as a plane is detected. So how would that look like? It looks like this. You have this hand, and it usually takes really only 1 or 2 seconds. If you don't want to use the AR fragment, but you use the AR scene view, then you have to do it on your own. But there's an on-update listener, which is called on every frame, and you just check if there was a plane detected that is actually in the tracking state, meaning Arcore is sure that it knows where it is, and that it is upward facing, meaning we want to look for tabletops or for the floor. And as soon as you find one of them, you can stop your animation. For Your Home app, we did something like that. The user should show us the floor, and then he sees some emojis he has to catch in order to find the plane. So that also was pretty fast, but much more work than just say, okay, just move your phone and you're done. So, time to free the llamas. Object placement is, again, super easy. You will just register an on-tap AR plane listener, and it does exactly what its name says. It gets called whenever the user taps on an AR plane. And in this case, we place an object there. And how do we do that? We get this hit result, and we create an anchor of it. Who already has worked with Arcore knows these anchors are the objects that specify a point in the real world that is tracked by Arcore, and however the user moves his phone, this point is fixed. And Sceneform adds the anchor node, which is basically the bridge between Arcore and Sceneform. So you give it a node, and you give it an anchor to this node, and a node is like usual in 3D programming, it's just a place in your 3D scene. And buying these two together, we can now attach a llama to this. So how do we create a llama? Would be interesting. So loading the model that we have created is just this one line. Model renderable builder set source. As you can see, your models are placed in the resource folder, so they are handled like any other Android resource. You can also put them in the assets folder if you like, but this way you always know that the naming is right. And when it's finished, we just assign it. Sceneform takes care of the whole loading. It takes care of dispatching it to a worker thread. So this a build method returns a completable future that we can then use to get the result of this background work. Then we create a node with this renderable. It's also just 2 lines of code down there. And you might wonder, what is a transformation system? That's something that's provided by the AR fragment, and it gives you support for all the standard gestures. So we use a Llama node that is a child, or it's a subclass of transformable node. And with transformable node, you get this scale controller, translation controller, rotation controller, which you can configure how this should work. For example, for the scale controller, you can set a minimal scale and a maximum scale so that things don't get too big or too little for your app to actually work with. For this one, for the Llama, we don't want to scale llamas. They come in the size they are. We don't want to move them around because they will move on their own, and we also don't want to rotate them, so we just disable all of this. But it's just for this kind of nodes. So for fences, they can just rotate, as you have seen in the first video. And the other part that is also provided by this transformable node is an onTap method. Usually it just calls select, and select will give you this nice little ring around an object that shows, okay, this is the currently selected object. All gestures are applied to this object, so if you move it or if you rotate it, that's the one that will be changed, but we don't want that, so we just want to start a little animation whenever the user taps on a Llama node. So if you come from something like Unity or some other more advanced 3D lib, you would expect that all objects behave like real objects. But unfortunately, in Sceneform, there's right now nothing like a good collision detection, nothing like I just say, okay, this one is solid equals true, and everything just works. You have to do the collision detection on your own, and even collision detection is it, but resolving is kind of hard because you don't get any information how much it is overlapped. So in a productive application, you would want to do some more complex stuff to maybe find the overlap so that you can really resolve it and make sure that objects don't overlap. For us, we just push one object away whenever there's an overlapping. So this resolve overlap, it checks whether one object overlaps with anything else. If this overlapping node is a heart, then we don't care because this is just an animation object. Doesn't matter. And otherwise, we take we make a vector between them and move it in the other direction so that these don't overlap anymore. And as this is called in the node onUpdate method, which is called in every frame, hopefully it will resolve fast enough that the user won't see any glitches. But yeah, it's not nice. You don't get like bouncing like you have for other engines where you just say, okay, these two objects, they are solid. They bounce when they touch each other. So hopefully Google will invest some time here and give us a better collision detection. What works really nice is shadows. You can just enable and disable it on every renderable. You have two sides of the shadow. You have one is the shadow caster, mean this object casts shadows on other objects. And you have a shadow receiver, means other objects receive or can cast shadows on this object. And if both are true for an object, the object also casts shadows on itself. So if you, for example, have, like with these llamas, they have like a head, and if the lighting would be right, then the head would cast a shadow on its own back. So usually that's the behavior you want. for any like real-world object that's like the default one. And you can also say, okay, when we detect planes like the floor, should there be shadows casted on these planes too? That's pretty nice because it's that's what you would expect, that is it a tabletop or the floor, objects should cast shadows on that. So yeah, you usually want to enable this, but then you have a little problem. If you take a look at the back, at the really top, it's a really straight line there. And with this video, you see that it basically, the shadow is only casted on parts of the plane where Arcore detected it as a plane. So it will now detect more parts of the plane, and so the shadows move. So in a worst case scenario, you might have just half of the shadow because the other part is not recognized. So for our sample app, that's kind of okay. For real production apps, you would probably disable this one and add your own fake floor that is really huge so that there are no boundaries where virtual objects would cut their shadows. So now we go to the animation part. There's really two nice ways. One is do it manually, meaning on every frame you just do something with your object, like changing its rotation or its scale, whatever you want to animate. And there's the easier part where you just use Android animations. So you can leverage your knowledge from Android development here by using, so that's first the animation we want to create. You tap a llama and then heart comes out, goes up, rotates while. So yeah, that's what we want to create. For the first part, for the going up and down part, we will use an object animator, like for any other Android animation. We set the values where it should animate from and where it should animate to. We say we want to animate the property local position, then duration and repeat count. And then that's the part that's Sceneform specific, as you set an elevator, and Sceneform provides you with a vector-3 elevator, which includes the logic to interpolate between different vectors. There's also another one that can be used to interpolate rotations. And yeah, giving this tool in your hand, you can create a heart, create an animator, and say just animator start, and it just goes up and down like you would expect. You can also set the usual interpolators on it, like you want to have an overshot or you want to have accelerate, decelerate, interpolation. Everything just works like you know it for other Android animations. And the other part would be our Sceneform animation. That's like I said, you just call on every on update. You just change the local rotation in this part. You just calculate some new degree that you want to have and just set it every time this one is called. So let's look at our sample app. We want to be able to place llamas in AR. Check. We want to allow touch llamas and get a reaction. We also did that. And llamas should move but avoid others, so we have collision detection that they don't overlap. So let's first do a, I think we have a bit of time left, and then I can tell you something about the tooling that we got from Google. Beside the Android Studio Sceneform plugin, we also get support for the Android emulator. which now has AR support. So you can change the back camera of an emulator to a virtual scene. This is basically, it's a little flat you would walk through. And you have two places for customization. If you want to do some image recognition, for example, in one room there's a big picture at the wall, and you can change this picture. And there's also somewhere something on the floor where you could also like place something like a QR code or your logo that you want to recognize. And you just navigate through the scene using the WASD keys, so like an ego shooter, just go through. And one downside is that right now it needs a graphic chip that supports OpenGL embedded version with version 3.1. So my early 2015 MacBook Pro does not support this, so we have to wait until they figured out how to do it. Yeah, so then let's go back to the summary. Sceneform is a great start for all of us to create own AR apps. And yeah, hopefully Google will add support for animated renderables soon. They promised it at the Google I/O to do this, so that you have like real walking animals in your games, and not everything looks that stiff and just glides around. So something more realistic. From my point of view, the documentation is a bit sparse at the moment. You have to jump through different documents. You have to look at the Java docs to find out why things behave the way they do. So hopefully this will also be improved. And yeah, so thank you for joining my talk. You can find the sample app on GitHub. This is also a QR code for people who don't want to type in that GitHub URL. You can find my company on Twitter. You can email if you have questions about Sceneform, or you want to start with your team, or your team already started and is stuck somewhere. So yeah, please just send me an email, and if somebody sketch noted the talk, I would also be interested in the sketch notes. So thank you.
So thank you, Steven, again. We still have 5 minutes for Q&A. There are 2 microphones on the side of the stage, and if you are in the middle, stuck in the middle, I can come and give you a microphone. The guy there? Okay.
So do you have a good sense at this stage, the cutoff point between using Arcore and Sceneform? What are the sort of the capabilities that you could develop using Arcore, but you can't using Sceneform? What are sort of the, and do you see some of those capabilities being built out in Sceneform over time?
Could you speak a bit louder, or could we put up the microphone?
Sorry, yeah, no, I think it's working now. Sorry, I'll say it again. Do you have a good sense of sort of the cutoff point between sort of Sceneform and Arcore? What are the sort of the capabilities, the things that you could do with Arcore that you can't do with Sceneform? And do you see some of those capabilities being built out over time?
So basically, Sceneform is just a renderer. So that it's a renderer that integrates nicely with Arcore. So you can do everything that Arcore can. You get access to all the Arcore specific, like a frame and an Arcore session. Everything can be accessed. So it's more like a nice add-on that also handles for you the Arcore part. So if you just want to use, if you do OpenGL drawing yourself, then there's no need to use Sceneform. Sceneform is more for lowering the barrier to start developing AR apps, because you don't need all this knowledge about OpenGL. So this is this whole OpenGL part is hidden from you, and also like loading models and.
Yeah, sorry, just quick follow on. So I guess that partly answers it as well. I mean, what do you see, in your examples, cases where you really you need OpenGL, and what are the sort of use cases where maybe you start using Sceneform and you realize you've hit a limitation, maybe you have to start using OpenGL code directly then at that point?
For the apps I didn't have the necessarily to use OpenGL. Of course, if you want to make of this example app like a game or more advanced sample, you want to start with animation of the objects. That's something you would have to do in OpenGL right now, because you don't have support for it. You don't have such advanced things like, for example, skeleton animations, something like that. And you also cannot access them nicely. So you cannot really start changing the renderable you have loaded. So that's pretty static right now. So that would be a point where you would say, okay, nice, but I cannot use Sceneform for this. And I'm also pretty sure that you cannot mix OpenGL and Sceneform, because Sceneform runs on a dedicated thread that is protected from your app, so you cannot easily access that one. So that would be a point for it.
So we still have time for one quick question. Is someone of you has one? Yeah.
So before you said that there is very little information about the objects to implement, like collision or things like that. But is there a way to have like the velocity of the objects to implement real physics?
Yeah, right now you don't have like a physics engine in Sceneform. You don't even have gravity. So whatever you do in case of collision detection or a physics like gravity, you would have to implement on your own anyway. So then you would have all the information you need to do that. But for example, if you want to just drop objects in the scene, you will have to do the animation or the falling part on your own.
Okay, thank you.